of successive approximation on the method of reversion of series, application of inverse interpolation. And this one, identify the problem of inverse interpolation, apply the various inverse interpolation with Lagrange's method, iterate towards successive approximation, method of reversion series, find a root given algebraic equation by using the inversion method we are discussing today here. So in this one, we are taking here earlier we learned, so after 7 units, various interpolation methods in finding the value of unknown data function y is equal to f of x corresponding to the specified value of x, that is the lies between two tabular values or before beginning after the ending tabular values. On the other hand, the converse of a four-step process is called inverse interpolation. That is the process of estimating the value of the argument x corresponding to the given functional value. When the latter lies between the tabulated values f of x and f of xj is called as inverse interpolation. And for some functions like y is equal to sin x or y is equal to log x greater than 0, you do not find any difficulty with the inverse interpolation we are taking here. In such cases, the required values of x can be computed easily by inverting the function and substituting the value of y. When y is equal to sin x, we have x is equal to sin inverse y. And when y is equal to log x greater than 0, we have x is equal to e power y. However, if the data function y is not known by set of the tabular values of x and y are given here, the process of inverse interpolation process difficulty here. In such cases, we usually seek the help of numerical method, and one of the following method, that is Lagrange's method, method of iteration, successive approximation, method of reversion services we are taking here. The Lagrange's interpolation method. What is the Lagrange's method? When the n+1 tabular values of f of xi, y, f of xi are either equally spaced, unequally spaced, we have derived the Lagrange's interpolation formula in which y is expressed as a function of x. So y is equal to f of x, x minus 1, x minus 2, and so on, x minus 8, xn. By division of, we are taking here using Lagrange's interpolation formula. When the n+1 tabular values of xi, y is equal to f of xi are either equally spaced or unequally spaced, we have derived the Lagrange's interpolation formula in which y is expressed as a function of x. F of x minus x1, x minus x2, x minus 3, and x minus xn. Therefore, x0 minus x1, x0 minus x2, then x0 minus xn, x0 minus xn, y0, then x minus x0, x minus. And what we are taking here, you have to listen here. This is x0, there is no x0 here. This is x1, there is no x1 here. This is x2, there is no x2 here. So, but in the denominator here, x0 is there, x1 is there. So we are taking, this is x0, we are taking this x0 minus x1, x0 minus x1, x0 minus x2, and x0 minus x3, and so on, x0 minus xn, up to that. Here also same, x1 minus x0, x1 minus x. Here also, xn minus x0, xn minus 1. So what is the fundamental we are taking? The x0 taking the first one, we did not take x0, x1 in the second function, we did not take in the numerator, and also x3 also we did not take in the numerator in third function. So upon interchanging x and y, we can now express x as a function of y is y minus y1 and y minus y2, and so on, y minus y minus y minus yn y minus yn we are taking here. By the denominator, what is by the denominator what we are taking here? By the denominator x minus x1, x minus x0 minus x1, x0 minus x2, and x0 minus xn up to so on. That is a multiply with what is the y0 value here. What is the value you are taking? X minus x naught, x minus x1 will be given. That is a function x1 value I'm taking here. This is a y1 value I'm taking. That's why we did not writing x1. X minus x2 and so on, x minus x1. Then the division what we are taking here, x0 minus x1, x0 minus x2 and so on, x0 minus xn. So minus x0, x1 minus x2, x1 minus x3 and so on. That's what the value is taking here. Then up to the end condition, x minus x0, x minus x1 and so on, x minus xn minus 1 by division, xn minus x0, xn minus x1 and so on, xn minus xn minus 1 to yn. Upon interchanging x and y, we now express the x as a function of y. So x is a function of y we are taking here, y minus y1, y minus 2, y2 and so on, y minus yn. Then y minus y0 minus y1, y0 minus y2 and y0 minus yn, that is x0 value we are taking here. Y0, y minus y0, y minus y2 and so on, y minus yn, y1 minus y0, y1 minus y2 and so on, y1 minus yn into x1 and so on, y minus y0, y minus y1 and so on, y minus yn minus 1. Division of yn minus y0, yn minus y1 and so on, yn minus 1 into xn we are taking here. So we are applying this formula to make inverse interpolation for a given tabular data. Obtain the value of the x when y is equal to f of x 0.3 by applying Lagrange's interpolation formula inversely to the following data. 0.4, 0.3683, 0.6, 0.332, 0.8, 0.2897. So given that we are taking here, x0 is equal to 0.4, x1 0.6 and x2 0.8, x3 x2 0.8, then y1 y0 0.3683, y2 0.3302, y2 0.2897. We are these values are taken here. So hence n is equal to find the x y is equal to 0.3. What is the finding of the value here? You have to use the Lagrange's interpolation formula. So n is equal to 2. What they are asking the problem following the data inverse formula 2. So therefore the difference is 2.4 to 1. So that's why. So we are applying the formula x equal y minus y1, y minus 2, y2 by division of y0 minus y1, y0 minus y2 into x0. Then immediately y0 minus y minus y0, y minus y2, y1 minus y0, y1 minus y2 plus y minus y0, y minus y1, y2 minus y1, y2 minus y1. Y0 and y1 are taking this x2. And if TD is there, you can write y0, y minus y0, y minus y1 and y minus y2, y2 minus y0, y2 minus y2, y3 minus y0, y3 minus y1, y3 minus y2, and x3 values we are taking here. What is the basic fundamentals? What the values is given here we are taking here. Then we are applying the values here. 0.3 minus 0.33 332. We are minusing the values from the above this one, and 0.2897 and 0.3683 minus 0.3 y1 y0 minus y1. Then y0 minus y2. What is the y2 value? 0.2897. What is the x0 is 0.4, x1 is equal to 0.6, x2 is equal to 0.8. So all the values are taking the value and simplifying the values here. 0.496 minus 0.496, 0.2764, 0.5306, 0.7574 I am taking here that all these values here. So therefore that 0.7574 here output value here. Apply Lagrange's interpolation formula inversely to find the value of x. 2 decimal points y equal to f of x 13.6 given the tabular data. 30 15.9, 35 14.9, 40 14.1, 45 13.3, 50 12.5. So therefore 30 35 40 45 50. So y0 15.9, y1 14.9, y2 14.1, y3 13.3, y4 12.5. To find x and y, use the largest interpolation formula, that Lagrange's interpolation formula, that is n is equal to 4. Because 1, 2, 3, n is equal to 4. So values here 0, 0, 1, 2, 1, 2, 3, 4, therefore total values is 4. Why? Because there is a 5 numbers is there, but what we are taking here 4 values only. Why? Because x0, x1, x2, x3, x4. We are taking here, that's why I am writing here y minus y1, y minus y2, y minus y3, y minus y4. By division of y0 minus y1, y0 minus y2, y0 minus y3, y0 minus y4. Why? Because in the denominator y4 writing here, the 4 values here I writing. This is y0 here taking the second one, y1 minus y0, y1 minus y2, y2 minus y1 minus y2, the third one y2. All the first values of y2, then y0, y1, y2, y3. Last y3, y0, then y4. The numerator part in the first value is y0, y1, y minus y1, y minus y2, y minus y3, y minus y4. Then plus into x0, y minus y0, y minus y2, y minus y3, y minus y4 into x1. Y minus y0, y minus y1, y minus y2, y3, y minus y4. The division of y2 minus y1, y2 minus y1, y2 minus y3, y2 minus y4. All the process are the same. Y minus y0, y minus y1, y minus y2, y minus y3. Then here y minus y4 they are taking here. But the denominator y4 minus y4 is there, the total is into 0. So that's why we are not taking that value, and also the fundamental formula we are following here. Then substituting the corresponding values in the formula. 13.6 minus 14.9, 13.6 minus, and all the values are substituting here. The x naught and y, x1, x0, x1, x0, what is the value of 30? X0 30, here 30, 35, 40, 45, 50, 35, 40, 50. You are multiplying all these values and concluding the value here, that is 43.14. So 43.14 means 43.14 only. 43.15 means you can take the 44 value here, but here we are taking here. Then method of iteration successive approximation. Using of Newton forward difference interpolation formula, this values the independent variable x are given x0, x1, x2, x3, xn, which are equally spaced with the interval different in h. X0 plus ih is equal to 1 to n. They have find x are given the value. The beginning of the tabular value is equal to choose the Newton forward difference interpolation formula. They are taking here y0 plus u delta y0 into u minus 1 by 2 factorial, delta square y0 into u minus 1, u minus 2 3 factorial, del cube y0. 3 factorial del cube y naught, then u into u minus 1, and so on, u minus n minus 1 by n factorial del power n y naught. Then u is equal to x minus x naught by h we are taking here. So therefore, we are taking the equation of the rearrangement, punarvinyasam. Rearrangement can be written as how we can rewrite u delta y naught is equal to u minus y naught minus u into u minus 1 by 2 factorial del square y naught minus u into u minus 1 u minus 2 by 3 factorial del cube y naught minus u into u minus 1 u minus 2 u minus 3 by 4 factorial y naught 1 by delta y naught by u minus y naught into u minus 1 by 2 factorial del square y naught u into u minus 1 by u minus 2 by 3 factorial del cube y naught u into u minus 1 u minus 2 u minus 3 by 4 factorial del y naught. So if you neglect the second and the higher order differences equation, you obtain initial or first approximation is equal to 1 by del y naught y minus y naught. So we call this is the first approximation to u and denote it by u1. Then u1 is equal by u minus 5 by y naught by delta y naught. To find the u2, the second approximation, that's one, you will take the consideration of the second order and find the difference from u is equal to u1. That term also we are taking here. First, u2 is equal to 1 by del y naught by u minus y naught. So minus of u1 minus 1 by 2 factorial del square y naught. To find the approximation, we take into consideration the third order finite differential u is equal to u2, the right hand side of the taking here in equation 2. The right hand side, what is the right hand side in the second equation? So that is this one del y naught, this is the del 4 y naught, this is the equation we are taking here. So 1 by u3 is equal to 1 by del y naught yu minus y naught minus u2 into u2 minus 1 by 2 factorial del 2 square y naught minus u2 into u2 minus 1 u2 minus 2 by 3 factorial del cube y naught. This is a process is to be continued. So you find the third approximation here, u3. We take into consideration the third order infinite difference also. U is equal to in the right hand side of equation. U3 is 1 by del y naught by u minus y naught. U2 minus 1 by 2 factor del square y naught minus u2 minus 1 u2 minus 2 by 3 factorial del cube y naught. This process to be continued until the convergence, not convergence, convergence here is related to consecutive approximation to two coincident of the degree of accuracy. U is equal to x minus x naught by h is the required approximate value. X is obtained, x is equal to x naught plus uh, where u is the convergent value. The procedure is known as the method of iteration of successive approximation, which is illustrated in the following example. Y is equal to x cube, x equal to 2, 3, 4, and 5. Find the cube root of 10. Correct three decimal places using the method of successive approximation. 2, 8, 3, 27, 4, 64, 5, 125. Here h is equal to 1. Now construct the forward difference table for the data. In the forward difference table data, we are taking 2, 3, 4, 5, 27, minus 8, 19, 64, 27, 37, 125, 64, 61, 37 is 19, 18, 61 minus 37, 24, 24 minus 18, 6, 2 minus 1, 3 minus 2, 4 minus 3. That is the values what we are taking here. So y is equal to 0, we take x is not is equal to, hence the successive approximation we are obtained by using equations 3 minus 5 in 1 of 8.3. The first approximation u1 is given by u1, u1 1 by del y naught, yu minus y naught 1 by 10, 10 minus 8, 0.1. The second approximation u2 for u is given by 1 by del y naught, yu minus y naught, minus of u1, u1 minus 1 by 2 factorial del square y naught. So 1 by 19, what is our value here? Taking here del y naught is 119. 10 minus 8.1, 1 minus 1 by 2, 18, that's 0.15. Now find the third approximation u3 for u is given by, we are writing yu minus y naught, u2 minus u2 minus 1 by 2 factorial del square y naught, u2 minus 1, u2 minus 2 3 factorial by del cube y naught. The simplification is 0.1532. We now use the equation repeatedly using the value of u3 obtained earlier in the subsequent step. First, the fourth approximation u4 is given by 1 by del y naught by u minus y naught minus u3 minus u3 minus 1 by 2 factorial del square y naught u3 minus u3 minus 1 u3 minus by 3 factorial del cube y naught they are taking here. So all the values we are substituting here. So 1 by 19, 10 by 1 by 19, 10 minus 8. So applying these values here 0.1532 minus 0.1532 minus 1 by 18. So these values are the total applying these values are 0.154. The fifth approximation u5 for u is given by we are taking here 2.1541, u.1541 minus 1 by 28, u.1541, 2.1541 minus 1, 2.1541 minus 2 by 6, we are taking 0.154. Since the desired is correct to the three decimal places, the convergence is deemed have been attained, we can stop further iteration. We are taking u4, u5 is equal to 0.154. This value substituting in this cube root of 10 x naught plus uh, 2 into 1.4 into 112 plus 0.14 is equal to 0.154. Then another formula, we are taking using the Stirling's interpolation formula. Y is equal to y naught plus u into del y naught plus del y minus 1 by 2 plus u square by 2 factorial del square y minus 1 plus into u square minus 1 by 3 factorial plus del cube y minus 1 plus del cube y minus 2 by 2. Therefore, u is equal to x minus x naught minus h. So by constructing the difference table and substitute the values of the various order infinite difference in the equation, we observe that the expressions inside the brackets are constants, denoting them a1, a2, a3, and so on can be written as yu is equal to y0 plus ua1, u square a2 plus and u into u square minus 1, a3 we are taking here. Equation 2 can be written as u1 yu minus y0 minus u square a2 minus u square minus 1, a3, yu minus y0 by a1 minus a square by a1, u square minus a3 by a1, u into u square minus 1. To obtain the first or initial approximation of u1 of u, we neglect all the second and higher order finite differences in equation 3. So yu minus y0 by a1, so that is the u1 value we are taking. Substituting the value, u1 is reduced in the equation. So neglecting the third higher order terms, we get second approximation, that is u2 of u. u2 is equal to yu minus y0 by a1 minus a2 by a1, u1 square. Substituting this value of u2 in equation, neglecting the fourth and higher order terms, we get third approximation u3 of u. u3 yu minus y0 by a1 equal minus a2 by a1 u2 square minus a3 by a1 u2 square minus 1. The iterative procedure is to be continued as in the earlier case until convergence in the value of u. Desired order of accuracy is attained here. That's why we are taking here x0 plus uh. We are taking here only. F0 16.35, F5 14.88, F10 13.59, F10 12.46, and X then F of X 14 using the method of successive approximation. 0, 5, 10, 15, 16.35, 14.88, 13.58, 12.14. So what they are asking, F of X 14, they are asking X0 is equal to 5. Why? What is the difference between 0 to 5? At 10 to 15, the difference is X0. So sorry, X0 is 5, X0 is 5, X0 is 5. We are taking here. So x minus x naught h by h is central. 5 we are taking here. 5 minus 5. 5 minus 5 by 5, that is 0. Then 5 we are taking here minus 1, 0, 1, 2. So applying the values of 16.35, 14.88, 13.59 and 12.46, we are taking here the value 14.88 minus 16.3 minus 1.47, 13.59, 14.8 minus 12.9, 12.46 and 1.13, 1.29 and plus and 0.18, minus and plus and 0.16, the plus and minus of the minus 0.12 we are taking here. Y is equal to 14. Hence the successive approximation obtained by using the equations. The first approximation u is given by yu minus y0 by a1. A1 is equal to delta y0 plus delta y1 minus 1 by 2. That is minus 1.29, minus 1 plus minus 1.47. We are taken minus of minus, that is delta plus y1 కాబట్టి plus into minus minus 1.38. So u1 is equal to 14 minus 14.88 minus 1.38. 0.06377 we are taking here. The second approximation u2 is given by yu minus y naught by a1 minus a2 by a1 u1 square. A1 is equal to what is the value is minus 1.38 here, minus 1.38 here, came here, a1 value minus 1.38. I'm substituting a2 is equal to del square y minus 1 by 2. I'm substituting here. So a2 is equal to 0.18 by 2 is equal to 0.09. The absolute value we are taking here. So 14 minus 14.88 by minus 1.38 minus 0.09 minus 1.38 0.6377 whole square. 0.06377.0265, 0.6642. The third approximation of the U3, U is given by U by YU minus Y naught by A1 minus A2 by A1 U2 square minus A3 by A1 U2 U2 square minus 1. A1 minus 1.38, A2 0.09, A3 del Q by minus 1 plus del Q by minus 2 by 12. So A3 is equal to minus 0.02 by 12 minus 0.0017. We are taking here. And U3 is equal to 14 minus 14.88 minus 1.38 minus 0.09 minus 1.38 0.6642 whole square. The total output here, after the simplification of this value is 0.6377, 0.024, 0.0288, 0.3205, that is equal to 0.667. Taking U3 as the convergent value of U is equal to 0.667. The required value of f of x is equal to 14. So 5 plus 0.667 into 5, this is the multiplier and the place. After the multiplication, the plus 5 is added here. So that is 8.335. Suppose a tabulated data, if you construct the finite difference table and observe that the second and higher order finite difference are very small, that is O into 10 minus, 10 minus 2, then we can formulate a quadratic equation for x, solve it for x and come to the solution. Illustrate the idea with the following example. The following table gives the complete value y is equal to f of x, sin h x for different values of x. Using the data, find x when sin h x is equal to 62. So applying these values here, 4.0, 4.81, 4.82, 4.83, 4.84, 60.7511, 61.3617, 61.9785, 60.6015, 63.2307. So applying these values here, that is sin h x is equal to what they are asking here, 62. X naught is equal to 4.8, this is the middle value, there is 5 values here. So middle value is 4.82. X minus x naught means x minus 4.82 by h we are taking here. So therefore that is a between. So 62, 0.01, 4.80, 4.81 and 0.01, there is a length of interval here. So x is 0 is equal to x minus 4.82 by 0. Y delta y del square y del cube y and del power 4y I am taking here. 4.80, 4.81, 4.82, 4.83, 4.84. That is minus 2, minus 1, 0, 1, 2. Y 60.60.7511, 61.3617, 61.9785, 62.6015, 63.2307. So del y 0. This is the minus I am taking here. 61.3617 minus 60.7511, 0.6106. 61.9785, that is 61.367, 0.6168. 60.6015 minus 61.9785, 0.6230. 62.237 minus 62.610, 0.562.6292. Then again I minus 0.6188 minus 0.6106, 0.6262. 6230 minus 6188, 62. 629 minus 6230, 62. 62 minus 6200 is 0, 62 minus 620, 0 minus 0 is equal to also 0. This differentiable we are framed here for the as per the formula. Using the Stirling formula, y is equal to y naught plus u into del y naught plus del y minus 1 by 2, u square by 2 factorial del square by minus 1 into u square minus 1 by 3 factorial del cube by minus 1 plus del cube by minus 2 by 2. Substituting the corresponding values from the table in this formula, 61.9785, that u into 0.6230, 0.6168 by 2 plus u square by 2, 0.0062. So therefore here, So y naught plus u del y naught del y minus 1 by 2, u square by 2 factor del square minus 1, u into u square minus 1 by 3 factor del q minus 1 del cube y minus 2 by 2. Substituting the corresponding values from the table, 62 is equal to 61.98785, u into 0.6230 plus 0.6168 by 2 plus u square by 2, 0.00062. So therefore, the value 31 u square plus 6199 u 0.2. So this is the not simplifying. So we are using minus b plus or minus b square minus 4ac by 2a. Minus b plus or minus under root of b square minus 4ac by 2a. Minus 6199 whole square. 4 into 31 plus 215 BAC. So that is the value 0.3407. I'm applying here x equal to x naught plus UH 4.82 plus 0.037 for 0.14.823. So method of reversion of series. The method of reversion of series is based on the initial assumption to the tabulated values of the function be estimated through the interpolation formula in terms of power series. So y is equal to f of x is equal to a0 plus a1x plus a2x plus a3x cube and so on. If a1 not equal to 0, y minus a0 by a1 is equal to u. The form we get x plus a2 by x1 x square plus 3a1 by x cube plus a4 by a1 x power 4. As a first approximation, we take u y minus a0 by a1. Equation 1, the reverse. The inverse of the function can be expressed as the power of series y minus a0 by a1 in the form x is equal to c1u plus c2 u square plus c3 u plus c4 u power 4. Substituting the value in the equation, we get c1 x plus a2 by a1 square, a3 by a1 by x cube, and so on, plus c2. And because చూడండి, we have to see here a2 by a1 a1 తీసుకుంటాం, ఇక్కడ కూడా a1 a2 a3 తీసుకుంటాం, ఇక్కడ a2 a3 తీసుకున్నాం, ఇక్కడ కూడా a2 a3 తీసుకున్నాం x లో. ఇది హోల్ స్క్వేర్ లేదు, ఇక్కడ హోల్ స్క్వేర్ ఉంది. ఇక్కడ కూడా a2 by a1 x square, a3 by a1 is whole power cube, this is whole power, but the value should be the same, powers will be different here. Which is the coefficients of like powers on x and both sides. C1 is equal to 2, 1, sorry, C1 is equal to 1, C1 by a2 by a1 plus C2 is equal to 0, C2 is equal to minus a2 by a1. So this is, we are taking that one, the value that goes to my plus a2 by a1 that goes to minus a2 by a1. Then coefficient of x power 3, a3 by a1 plus 2c2 by 2 by a1 plus c3 is equal to minus a3 by a1, 2 into a2 by a1 whole square, c1 by a4 by a1 plus c2 by a2 by a1 whole square, 2c2 by a3 by a1 plus c3, 3a2 by a1 plus c power 4 is equal to 0. C power 4 minus a power 4 by a1 equal minus a2 by a1 whole square, minus a2 by a1 minus 2 a3 by a1 minus a2 by a1. All these are simplifying here. The possible to minus a4 by 1 plus 5 a2 by a3 by a1 whole square minus 5 a2 by a1 whole cube. So we now use a particular interpolation formula like Newton's forward difference interpolation formula, form a power series and compute the values a0, a1, a2, a3, a4 in each case. In general, the fourth and other higher order finite differences are usually very small. Hence, we shall took into consideration up to fourth order finite differences only for the computation purpose. Now illustrate the method with Newton's forward difference interpolation formula. Consider the Newton's forward difference interpolation formula, neglecting the fifth and high order differences we are taking here. Y is equal to y naught plus u del y naught into u minus 1 by 2 factor del square y naught into u minus 1 minus 2 3 factor del cube y naught into u minus 1 u minus 2 u minus 3 by 4 factor del 4 y naught. We are taking that is x minus x naught by h. After expressing this equation, y is equal to a naught plus a1u plus a2 u square plus a3 u2 plus a4 u4. Comparing like terms in these two equations. A naught is equal to y naught, a1 is equal to del y naught minus 1 2, 1 by 2 del square y naught, 1 by 3 del cube y naught minus 1 by 4 del 4 y naught. So a2 is equal to 1 by 2 del square y naught minus del 1 by 2 del cube y naught plus 11 by 24 del 4 y naught. A3 is equal to 1 by 6 3, 1 by 6 del cube y naught minus 1 by 4 del 4 y naught. A6 is equal to 1 by 24 del 4 y naught. What is the values we are taking here for consideration here? Given that f of 44 is equal to 13.40, f45 is equal to 13.16, f46 is equal to 12.93, F47 is equal to 0.68 and f of x is equal to 13. Find x by reversion of series by method using Newton forward interpolation formula. We first consider the difference table for the given data. 44, 45, 46, 47. So where f of x equal to 30.40, 30.16, 12.93, 12.68 we are taking here. So delta y value they are given here. So therefore I am taking here 13.16 minus 30.24, 12.93 that is 0.23, 12.68 to 0.25, 0.23 plus 0.24 minus 0.1, 0.25 plus 0.23, 0.02. Both are plus this minus 0.03, the output value here. Following the Newton forward differential interpolation formula and equations, a naught y naught is equal to 13.40, delta y is equal to minus 1 by 2 del square y naught by 1 by 3 del cube y naught minus 0.04, 1 by 2 0.001 minus plus 1 by 3 0.03. So a1 del y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught we are taking here. Let's apply the value of minus 0.24, then my minus 0.05. So that is the values applying here minus 2.005. Then a2 minus 1 by 2 del square y naught minus 1 by 2 del cube y naught. So applying the value minus 0.005. From equations 4, C1 is equal to 1, C2 is equal to minus A2 by A1 minus 0.02 by minus 0.2 that is 0.084. 0.0784 we are taking the values here. So C3 is equal to minus A3 by A1 plus 2 by A2 by A1 whole square minus 0.05 minus 0.255 plus 2 into 0.02 by minus 0.255 whole square minus 0.0196 plus 0.0123 minus 0.0073 we are taking here. C for 5 A2 A3 by A1 square minus 5 by A2 by A1 whole cube. That is the value is 5 A2 0.02, 0.005 by division A1 value is there and 0.255 that is the value simplification is minus 0.0053 the output value output coming here. Also we have u is equal to y minus a naught by a1. So y is equal to a naught by a1 that is the y is equal to u minus a naught by a1. 13 minus 13.0 the output is 15.686. So what is the fundamental of x equal to c1 plus c2 u square by c3 e3 c4 u4 I am taking here. There is a value 1.686 6x whole square 6x whole cube 6x whole for 4 that is 1.7012 the total output value here. Since the assumed origins here x is equal to 0 1 the desired, so 1.0712 multiplied to 44 plus 145.7012 is the output value we can write here. Then application of inverse interpolation, find integration a real root of the algebraic equation. Suppose to find the real root of algebraic equation f of x is equal to 0, to find an interval in such that root of f of x is equal to 0 and the tablet x, f of x taking an interval in the neighborhood of the root. Then approximate f of x is polynomial is considered interval by applying a simple difference formula says Stirling formula. In this polynomial equation, in the terms of higher equation degree exhibit very little influence in the convergence process. Hence, the approximation to the required root can be found, and this can be improved further by successive approximation method. We now illustrate this procedure through the one example here. X cube plus x minus 3 is equal to 0, which lies between 1.2 and 1.3. We consider a neighborhood of interval 1.1.3, namely 1.0, 1.4. X is equal to 0.1, y is equal to f of x. x cube plus x minus 3, x naught plus u is equal to 1.2 plus 0.1, where u is determined. We now consider the central difference table 1.0, 1.1, 1.2, 1.3, 1.4. U is equal to x minus 1.2 by 0, 1, minus 2, minus 1, 0, 1, 2. So y is equal to f of x, x2 plus x minus 3. So what is the values here? We taken here the values 1, 1, 1, minus 1, minus 2 plus minus 2. X cube, we have to substitute in this value, in this value. So the output, all these values came here, minus 1, 0.569, and 0.072, 0.187, 144. After this statement, I have taken the minus here, minus 0. Minus 1, then minus 4, 0.431, 4.97, this is 569, this is 0.647, this is 0.06, this is 0.72, this is 0.78. This minus 6.6, this is 6.6 minus 0.6 is 0, the output value written in L4 line. Here using the scaling formula, y equal y naught plus u del y minus 1 plus del y naught by 2 plus u square by 2 factorial del minus 1 plus u to the square minus 1 by 3 factorial del cube y minus 2 plus del cube y minus 1 by 2. So such that y naught equal to 0, minus 0.002, 0.569 plus 0.497 by 2 plus u square by 2 plus 0.072, 0.006, 0.006 by 2. So minus 0.072, minus 0.533. All the simplification values we are writing here. So therefore, u1 is equal to 0.072 by 0.53, 0.1353. So substituting these values here, 0.1353 in right hand side, second approximation due to 1.53, 1353 minus 0.03 by 0.532, 0.1353 whole square, 0.001 by 0.532, 0.1353 whole square, 0.1341. U2 is equal to 1341, the right hand side equation 0.151353 minus 0.306 by 0.532, 0.1341 whole square, the same as 0.001 by 0.532 minus, and all the values are substituting here, therefore 0.01341. This is also 0.431. This is also 0.131, this is also 4.31. So this value of x cube value is 1.2, 0.1341 to 0.1, that is 0.12134. So in this unit we learn that the technique determines the value of the argument corresponding to the eigenvalues and the function lies between two translated values. You have learned the Lagrange's method, the method of iteration of successive approximation, the method of reversion solving by the inverse of interpolation problem. As an application of the inverse of the interpolation technique, method of finding real, then the polynomial is dealt with also is illustrated. This is the unit. So in the examination, what they will ask? There are 4 blacks, black 1 3 units, black 2 3 units, black 3 units, black 4 4 units. So in the short question, the 4 marks, the 5 marks question, black 1 and black 2. 1 mark, 4, 5 marks, black 2 also 2 questions, black 3 are 2 questions, black 4 are 2 questions. You have to write any 4, irrespective of black. But in the second one, black 1, you have to mandatory do 1 black 1, 2 questions given, 1 black 1, 2, 3. 2 questions given, 1, 2, 3, any black 1, 2 are black 1, 3 are black 2, 3. So the same as block 2, block 3, block 4, they are given 10 marks. In block 3, whereas total group we are given 2 questions, 13 and 14, the 20 marks question you have to write any one question. This is the examination. This is any doubts asked, please.